Uh, Today we will see GATE Instrumentation Engineering syllabus for 2023. So as we have seen even earlier also, the GATE syllabus actually remains same, most of the time. Most of the time it remains the same and there is no much difference. So for the students who are learning it for the first time, so I will like to say that it is more or less the same. So you can take it as base and start your preparation. Next is subjects. Actually, you have 10 subjects. Like first is engineering mathematics, electricity and magnetism, electric circuits and machines, signals and system, control systems, analog electronics, digital electronics, measurements, sensors and industrial instrumentation, communication and optical instrumentation. So these are all the 10 subjects. For engineering mathematics, as we have already seen in one of the videos which I have posted earlier in my YouTube channel, like first is linear algebra, wherein you have matrix algebra, systems of linear equation, consistency and rank, eigenvalue and eigenvectors. Then next is calculus, mean value theorems, theorems of integral calculus, partial derivatives, maxima and minima, multiple integrals, Fourier series, vector identities, line, surface and volume integrals, Stokes and Gauss and Green theorems. Next is differential equations, first order, second order, linear differential equation with constant coefficient, methods of variations of parameters, Cauchy's and Euler's equation, initial and boundary value theorems, solutions of partial differential equations, variable separable method. Next is analysis of complex variables, analytic functions, Cauchy's integral theorem and integral formula, Taylor's and Lorentz series, residue theorem, solution of integrals. Next is probability and statistics, sampling theorems, conditional probability, mean, median, mode, standard deviation and variance, random variables, discrete and continuous distribution, normal, Poisson, binomial distributions. Next is numerical methods, wherein you have matrix inverse, solution of nonlinear algebraic equation, iterative methods for solving differential equation, numerical integration, regression and correlation analysis. This is for engineering mathematics. Next is electricity and magnetism, where you have Coulomb's law, electric field intensity, electric flux density, Gauss law, divergence, electric field and potential due to point, line, plane and spherical charge distribution, effect of dielectric medium, capacitance of simple configuration, Bird-Stewart's law, Ampere's law, curl, Faraday's law, Lorentz, inductance, magnetomotive force, reluctance, magnetic circuit, self and mutual inductance of simple configurations. This is subject. For subject 3, electric circuits and machines. You have voltage and current sources, independent, dependent, ideal and practical, VNI relationships of resistor, inductor, mutual inductance and capacitor, transient analysis of RLC circuits with DC excitation, Kirchhoff's law, mesh and nodal analysis, superposition, Thevenin, Norton, maximum power transfer and reciprocity theorems, peak, average and RMS values of AC quantities, apparent, active and reactive powers, phasor analysis, impedance and admittance, series and parallel resonance, locus diagram, realization of basic filters with RL and C elements, transient analysis of RLC circuits with AC excitation, one-port and two-port networks, driving point impedance and admittance, open and short circuit parameters. Next you have for machines, you have single-phase transformers, equivalent circuit, phasor diagram, open circuit, short circuit tests, regulation and efficiency, three-phase induction motors, principles of operation, types, performance, torque speed characteristics, no load and blocked rotor tests, equivalent circuits, starting and speed control, types of losses and efficiency, calculations of electric machines. This is third chapter, signal, and this is subject number 4, signals and systems, wherein you have periodic, aperiodic and impulse signals, Laplace, Fourier and Z transforms, transfer function, frequency response of first and second order linear time invariant systems, impulse response of systems, convolution and correlation, discrete time system, impulse response, frequency response, pulse transfer function, DFT and FFT, basics of IR and FIR filters. And section 5 is control systems. You have feedback principle, signal flow graphs, transit response, steady state errors, Bode plot, phase and gain margins, Routh and Nyquist's criteria, root loci, design of lead lag, lead lag, compensators, state space representation of systems, time delay systems, mechanical, hydraulic and pneumatic system for components, synchro pair, servo and stepper motors, servo valves, on off PPI, PID, cascade, feed forward and ratio controllers, tuning of PID controllers and sizing of control valves. For analog electronics, you have characteristics and application of diodes, inner diode, BJT and MOSFET. Small signal analysis of transistor circuits, feedback amplifiers, characteristics of ideal and practical operational amplifiers, applications of op-amps, adder, subtractor, integrator, differentiator, difference amplifier, instrumentation amplifier, precision rectifiers, active filters, oscillators, signal generators, voltage control oscillators. This is 7. Subject digital electronics, wherein you have combinational logic circuits, minimization of Boolean functions, IC families, TTL and CMOS, arithmetic circuits, comparators, Schmitt trigger, multi-vibrator, sequential circuits, flip-flops, shift generators, timers and counters, sample and hold circuit, multiplexer, analog to digital, successive approximation, integrating flash and sigma delta, and digital to analog converter DAC, weighted R, R2R, ladder and current steering logic, characteristics of ADC and DAC, resolution, quantization, significant bits, conversion, setting time, basics of number systems, embedded systems, microprocessor and microcontroller application, memory and input-output interfacing, basics of data acquisition system, basics of distributed control system, and programmable logic controller. For measurements, you have SI units, standards, RLC, voltage, current and frequency, systematic and random errors in measurements, expression of uncertainty, accuracy and precision, propagation of errors, linear and weighted regression bridges. You have Wheatstone, Kelvin, Mega Ohm, Maxwell, Anderson, Schering and Beam for measurement of RLC, frequency and Q meter. Measurement of voltage and current and power in single and three-phase circuits, AC and DC current probes, true RMS meter, voltage and current scaling, instrument transformer, timer counter, phase, time and frequency measurement, digital voltmeter, digital multimeter, oscilloscope, shielding and grounding. For sensors and industrial instrumentation, you have resistive, capacitive, inductive, piezoelectric, Hall effect sensors, and associated signal conditioning circuits, transducers for industrial instrumentation, displacement. You have linear and angular velocity, acceleration, force, torque, vibration, shock pressure, including low pressure, flow, variable head, variable area, electromagnetic, ultrasonic, turbine and open channel flow meters, temperature, thermocouple, bolometer, RTD, thermistor, pyrometer and semiconductor, liquid level, pH, conductivity and viscosity measurement, 4 to 20 milliampere, 2-wire transmitters. The next one, the final one, communication and optical instrumentation. You have amplitude, the frequency modulation and demodulation, Shannon sampling theorem, pulse code modulation, frequency and time division multiplexing, amplitude, phase, frequency, quadrature, amplitude, pulse shift keying for digital modulation, optical sources and detectors, LED, laser, photodiode, light dependent resistor, square law detectors and their characteristics, interferometers, applications in metrology, basics of fiber optic sensing, UV, VIS spectrophotometers, mass spectrometers. So as we have seen, so basically we have 10 subjects, and I think it is a very good time to look at these topics and understand what we have to do, so that a roadmap can be prepared and the preparation can be started, so that we can achieve a very good result in the upcoming GATE exam. Thank you very much.